Hello everybody, Caveman Math here, back with another video. And in today's lesson I'm going to be catching up with piecewise functions. Now I kind of delayed this one from the last video, but in today's video I will be describing in depth how to solve this and understand piecewise functions. So first thing you need to do is take it piecewise, hence the name piecewise functions. You look at these individual functions, right? And I think the most important thing that you need to know about piecewise functions is that this side of the function demonstrate your y's, right? And this side demonstrates your x, or your domains, right? And your domains are kind of your determinants to what values you can plug into tables, right? So speaking of tables, let's start with a table. All right, if we start with our table, let's start with this first. Let's take it piecewise, right? X plus 2, right? That's absolute value. You already know it's a V shape like this, but let's see how it turns out on the paper. All right. All right. Well, that is a bit crooked. Anyways, our domain is everything that is greater than -1, which basically means, or sorry, everything that is less than, sorry, my bad, everything that is less than -1, right? Because it's like less than, sorry. Yeah, everything that is less than -1. So what is less than -1, right? You obviously got, -1, you got -2, you got -3, you got -4, you got -5, right? And what you got to do now is plug these back into the y, right? Or the x plus 2, right? So what you do now is you do -1 plus 2. What does that equal? That equals 3. Just put that in, just plug and dump basically. -2 down here, that becomes positive, that becomes 4. So now you put it here, and now you bring the -3, you plug it in, and now when you plug that in, it becomes positive because absolute value always makes the numbers positive. So it's just 3 plus 2, which is 5, right? And then -4 goes in there, 6, -5 goes in here, and that becomes 7. There we go. All right, we got a full setup. Now let's start graphing this. 1, right? And then you got -1, so -1, 2, 3. Let's go. We have our first point down. Our second point is -2 and 4, right? So -2, and then you 1, 2, 3, 4. There we go. We got -3 and 5. 1, 2, 3. 1, 2, 3, 4, 5. This kind of goes out the boundaries. So you got this, and then you got it out of the boundaries. So you go here, and that is our for the first one. That's our first piecewise. Wow, we've made it this far. All right, let's shrink this a little bit so it can fit the rest on the page, because there's going to be a lot. All right, let's get back to it. Next one, we're going to take this piecewise as well. All right, what does this tell you? First off, let's look at this. Most importantly, our domain states that we have numbers between -1 and 2. -1, we locate that on our graph, and 2, which is here, right? Once we've done that, we already know what we need to plug in, right? So with that, you're just going to be like, okay, x squared y, and then you're gonna plop them down. You're gonna be like, well, okay, -1, you got 0, you got 1, you got 2, right? And pay attention, because this is not included, right? And what it means by not included is that you're not going to have a full circle as you're putting these in. You're going to leave it a blank, an open circle. And so let's start by plugging them in, yeah? So -1 plugged into x squared, right? So we got negative 1 x squared. That's, you already know it's 1, right? So we got 1. Let's erase these. We got negative 1 and 1, right? And what else do we have to do? 0, plugging in, you got 0, you already know. And you got 1, you plug it in, you got 1. Plug it into 4. All right, let's start graphing these, yeah, for the second one. We got negative 1 and 1. Let's do this. Negative 1 and 1. So this one is going to be an open circle like this because it's not included, because it's the negative 1 as the domain. All right, now this one is included. These are included. You got 1, 2, 3, 4. You got this one, and then you got 1 and 1. There you go. Now you just draw it up. There you go. That is how you do that part of the piecewise. All right, let's go for the next part of this piecewise function, which is the bottom half. So you got the bottom half down here. All right, let's approach it the same way we did with all of them. We got 2x. You already know. All right, let's start. Our domain is x greater or equal to 2. So what this basically means that every value that is greater than 2 or equal to 2. All right, let's start with it. We got 2x, that looks like a z, 2x, and then we got y, right? And essentially what you have to do is you put it down. You got 2, right? You already know you got the 1, right? And you got the 0, and then you got the 1, negative 1, you got the negative 2, you got a negative 3. All right, let's do 2. You plug it in here, you get 4. Plug 1 in, you get 2. 0, you get 0. Negative 1, you plug in, you get negative 2. You plug in negative 2, you get, wait up. Wait, did I say anything greater? Oh boy. Wait, I need to think about this. I'll be right back. Sorry boys, I'm back with this one. I kind of misled you guys. It's everything greater than 2. That is true. Everything greater than 2 does not mean negatives. 2, 3, 4, 5. Alright, you plug in 2. Right? When you plug in 2, you get, well, 4. When you plug in 3, you get 6. When you plug in 4, you get 8. When you plug in 5, you get 10. All right, let's start graphing these. You got 2 and 4. You got 1, 2. And then 1, 2, 3, 4. Right? Okay, this is evidently... That is included. That's included. That is included. All right. Yeah. Okay, that makes sense. So, all right. You got 3 and 6. You got 1, 2, 3. 1, 2, 3, 4, 5, 6. You got it out here, right? So it seems like this is actually gonna drag on. So you got what else? 4 and 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Right? Essentially, it just keeps going up like this. And that there is your piecewise function for that one. That is how you graph it. Right? And now you got the second part, which is this one. You got this one, right? Let's go through this quickly. You got negative x, you already know it's reflected. This is basically all of the values that are less than 0. So less than or equal to 0. So let's get to it. You got x squared negative, right? And then you got y. And then you already know you gotta have 0, and you gotta have -1, -2, -3, -4. You plug them in, 0, 0, 0 becomes 0. And then when you plug in a -1 squared negative, so this, you already know it becomes positive. So it's like, oh wait, okay, you already gotta do this one. So exponents first. When you do this, it's still negative, so it's still -1. Wow, that's crazy. PEMDAS really comes in handy. All right, -2, -2, you already know, plug it in. 2, PEMDAS first, exponents first, 2, -2. Right, same goes, actually not -2, sorry. -4, you already know. And then you got the next one, which is just the same one. So it's just -3, and that's just -9. Same thing here, 4 times 4, 16. There you go, -16. All right, let's start graphing these. Okay, you got 0, 0, you got -1 and -1, you got -2 and 4, so 1, 2, 3, 4. Got it down here, and then so on and so forth. 3 and 9. Keep in mind, these are included points, so they are going to be off our radar. Here, let's mark these because we don't want to lose them. Okay, there we go. All right, next one. 4. This is called a constant, and essentially we have it between 0 and 3. Now 0 and 3 is here, 0, and you got 1, 2, 3 here. So you got everything between all that. So let's go for it. But you got to remember the 0 is not included because it's this. Yeah. All right. Let's get it. So y, and then you already know you got your 0, right? And then you got your 1, and then you got your 2, and then you got your 3, and then that's it. So when you go up to there, yeah, you got 0, 1, 2, 3. You plug in 0, 0 is just, well, that's just not there. Wait, what? Okay, why am I even doing this? This is literally a constant. It just goes. You don't even need to do all that for a constant. So when you've located your constant, it's just 0. Well, you know it's 4. This is your y. So it's just up here. It's just 1, 2, 3, 4. It's just here. And then I think this is included, not included. And you go, and I think that's it, just your constant. All right, let me double check. I have double checked this review. I was wrong. This does not actually go to infinity because it, as I said, it has a limit. It has a domain, and it gets limited here, exactly here at 3. I'm so sorry for these little tiny mistakes. Now let's go. We got 2x minus 6, right? And we got x greater than 3. Essentially, what this means is that all values that are greater than 3. All right, let's write it down. So we got 2x minus 6, and then we got 1 as y, sorry. All right, let's see what's greater than 3, yeah? We got, all right, we got, first off, we got to write 3 down. I mean, not really, we can't, can we write, you know, it is not included. So we still got to write it down though. All right, we got 3. When you plug in 3, you already know. All right, after coming through this, I already know you got 3 and 0, right? And then you got to put down the rest. You got 4, 5, and however many you need, really. But I think these 3 are doing fine just now. Let's do it. I mean, let's do 6 as well. All right, let's plug in 4. You got, well, 8. 8 minus 6. You got 2, right? And 5, well, yes. Okay, 5 times 2, 10. 10 minus 6, 4. You got 4. You got 6 times 2, 12. Right? What does that give you? Perfect 6. Okay, let's go. All right, so you got 3. Right, got 3, 0. So where's our 3? 3 is 0. Okay, what's our 4 and 2? You got 4 here. You got 2 here. Right, it's going down. You know, you got 5 here. Now it's, what is the, I'm sorry, something just went off in the background. I had to pause for a little bit. But when you go down here, you got 5 and 4. Which is 1, 2, 3, 4. Right, you got 5 and 4, and it's down here, and you got 6 and 6, which is just out of the grid, right? And essentially what that does is just this over here, right? And let's pay close attention. This is not included. Do not forget to show that it is not included. All right, let's answer check with the key. Let's see if it's correct. I did something wrong. Now let's see what I did wrong, right? Because this is clearly not the right way to write it, right? So let's check it out. All right, we got it the wrong way. So I'm assuming that it's the other way around. Alright, I ended up actually drawing that wrong and looking into the negatives. I literally forgot that negative quadrants existed. That's crazy. Alright, you got 4 and 2. 1, 2, 3, 4, 1, 2. You got to go up. Right, now you got 5 and 4. Oh my god. You got that and that. And yeah, you got it there. Now you got, well, 1, 2, 3, 4. That's 4 and 2. No. Cancel. I don't want to show you my camera. Alright. Yeah, that was wrong. Sorry. There you go. Alright, 5 and 4. No, 5 and 4. 5 and 4. 6 and 6. That's just out of the grid. Alright, let's draw this. And now you have the right graph. Sorry for drawing it wrong. Alright, now what you need to do right now is you need to solve these, right? You got f of negative 5, right? You got to plug these in and find them out. So let's do it for this side. You got to split them. Alright, negative 5. You got to see what negative 5 can actually plug into, right? And now negative 5 cannot plug into this, and it can definitely not plug into this, but it can plug into this one because, well, it's less than 0. So let's try plugging it in, right? We got negative 5, we got negative, and then you got negative 5. Well, what does negative squared do? So it's just, 25 casual negative 25, right? Oh my god, low power mode, here I come. Let's turn this up. All right, f of 1. Right, you got f of 1. Now you're plugging this in. Where are you plugging it in? It's 1, literally 1. Now, my recommendation would be to just plug it into this one because it's 0, 1, 2, 3, right? So now if you plug it into 4, well, you can't really do anything with that. But here, I'll figure it out right now. As I predicted, well, can't really do anything with that. It's just 4. All right, let's go to the next one. You got 3. Where can you plug in 3 to? Well, all right, let's see. We got, honestly, let's just let's just plug it into this one. Yeah, 2x minus 6. Let's try it. Let's see if it matches up. 2x, so 2, 3 minus 6. That's 6, that's 0. Let's see if it's correct. According to the key, it is not correct. Now let's see where I messed up. Right? You can clearly not plug it into this one because it is all numbers that are greater than 3, right? And I don't think 3 is included in greater than 3. So what I can do now is 3 times, Nothing, actually. You can't really do anything because the only thing that 3 plugs into is 4, which you can't plug into anything because there's no x here. So it's just 4 again. That's crazy. All right. We got f of 10. Okay, now f of 10 you can actually plug into this one, which is 2, 10 minus 6. Now that is something you could plug in, right? And that would be 20 minus 6. Big brain math. 4. Oh my god, that is wonderful. All right, let's go on with the other ones. All right, we got -5. All right, what is less than 5? Well, we already know. Let's see. We got all of this, right? All of this in here. So if you plug in -5 into these absolute values, plus 2, you already know. You got 5, 6, 7. You got 7 down. 0. All right, what constitutes a 0? Well, you can look at x2 here because between them is a 0 because -1, 0, 1, 2. All right, let's already plug it in. We got 0 to the power 2, which is just 0. All right, -1. Let's go for -1. -1. Let's see where we can plug -1 in. Let's go for... Yeah. Let's go for the top one. Let's go for the top one, because if we plug into the top one, we'll just get 3. Let me answer check this. I'll be right back. I was correct. The answer sheet clearly stated that it is everything basically more. So more than -1. Well, we got 3 here. All right. Let's see. 5. F of 5. What can we do with this? We can plug it into this one because it's everything more than 2. All right, let's go for it. 2, and you got 5, which is 10. All right, we're done with that. Now, this is the tricky part. Getting to write the equation for piecewise functions. This is by far the hardest one I've had. Right, because I genuinely don't know sometimes, because I'm still learning this. I'm still learning this topic very well. But in this video, I will try to show you the most correct way possible. So first, I would identify our domain, which is, well, let's look at the constant, I guess you could say, because I mean, not really, because there is a linear here, and I think linears should be covered first. So you already know you got -1. Right, -1. Okay, what does that tell us? That tells us that the range is probably like, because it's also included, so it's more than -1. So it's less than negative. Is it? Is it like? Yeah, it is less than -1. So evidently it is less because it's going towards this side. Now, when it is less, well, you can just put it in to this one. Right, you got -1, so it's less, everything less or equal to -1. We got the domain for that one on lock. Now, these ones are pretty easy to pinpoint because they are indeed not included. All right, let's take these first spin. So you already know we got the -1 here, which is our domain, right? And you got, well, it's not included, so you already know you got to put this without that sign underneath it. All right, now you got 3. Right, and it is not included again, so it's just going to be x and then 3. All right, we got that covered. Let's take a look at the other one now. Now we got, all right, which way is this going? We got x, right, and it is not included, right? We got an x and we got a 3. Right, now which way is this sign going? Right, okay, now we know that this sign is going this way because this arrow is pointing this way. Let me double check on that. Apparently it was right. All right, now let's get rid of the constant. We got 4 in here, right, and you already know we got to drop this with the x. Wait, what? Okay, let me contemplate a little bit on this. You already know we got the x squared minus 3 and the negative 2x minus 1 because it's negative linear. And this is that. And that it translated 3 down. Alright, thank you for watching this video. I will catch you guys later. Stay hungry and learn math.